Good morning. How are you guys doing? It's not working. All of you? Oh my God. The password or? Oh, okay. Try beta 2 agonists. Looks like I forgot my password. It did not work? It did? Cool. Yes, you have a question over there? Okay, restart. Try to restart the device. I received many emails, guys. I just want to share with you something. I received many emails about the point distribution for the final exam. So let me share this information with you guys, okay? Okay, so the final exam will be just like the CAT, the same format. We'll have multiple choice, true, false, matching, okay? Just like CAT 1 and 2. And then you will have 63 questions, okay? Now, 26 of these questions will be for Dr. Pearson, and 37 will be my questions, okay? For my portion, about 31 of these questions will be on the material we covered after CAT 2, okay? And 6 questions will be on the material we covered before CAT 2. But notice I said it's approximate because there are many topics that are, you cannot separate them, right? So when we talk about agonist, antagonist, induced fit, potency, efficacy, you cannot separate them from, material in CAT 1 or CAT 2, okay? For Dr. Pearson, you will have to check with him, okay? But roughly, there should be about 21 to 5, the portion. But again, I cannot speak on his behalf. I mean, he could choose to put all his 26 on the first material or on the final. That's totally up to him. You'll have to check with him, okay? But I know for sure 26 questions will be on his material, 37 on mine. Like I said, about 31 of these materials, of these questions will be on the topics covered after CAT 2, and only 6 questions on before that, okay? But the ones actually before CAT 2, like I said, we learned about the basics. So you will see, these concepts you need to know to be able to answer the 31 questions. Does it make sense? Okay, good. So any question? Yes. That's a good question, and I can answer this question. So her question is, would these 6 questions will be, taken away from, the same questions we've seen in the CAT? I mean, you hope wishful thinking, I should say. No, I mean, most likely I'll come up with, 6 different questions, okay? What? The same concepts, yeah. It's gonna cover them. Not gonna like test you on something that we have not learned, right? All right. Any questions about this? Any concerns about the final exam? It's gonna be next Monday, 9 to 12. Okay, and it's gonna be an individual component only, no team-based. Okay. What else? Yes, Kendra. How long does it take to what? I'm sorry. Receive results? Okay. For that, exam because we'll have to, based on the results, some people might choose to retake the exam. You guys know that there is a chance for reassessment to retake the exam. Okay, so for the final, okay, Dr. Al-Khatib should explain for you better, but the short answer is, if you take the final and your individual component is below 70, then you will have the chance to take the, another final, and but the maximum you could score on that second final is 70%. That's it. So even if you score 100% in the final, then that's part of being penalized of taking another final exam again, another chance. So the maximum you can receive is 70%. Okay, but again, this is the first time we're doing this reassessment thing this year. So please check with Dr. Al-Khatib. Okay. Now, to answer your question, that's why I'm not sure I'll be able to release the results or not, because there might be some students who will have to retake the exam. So let me think about that. I'll let you know, okay? Yes, John?
You don't happen to know if we have that option for other tests? Like, I know you
mean other courses like IL and AP and...
Other than the final. Like
oh, no, just the final. Just the final, yeah. Yeah, only the final. Yeah. Well, it's... yeah, I mean, that's the way it's been set up, okay. Right, any issues about the final? Yes, sir. I'm sorry. How long? 63, I think. 2.5 hours. Okay. Yes. Say it again. Can the exam be on Wednesday? No, I cannot set up the time for the exam. I'm sorry. This is the academic affair office, and they wanted all the finals to be on Monday, such that people who have to, if someone, hopefully nobody will have to, but if someone has to retake the final, then we have time for them to take the exam and release the scores within a week for everyone, okay? So, okay. And we will have a review, okay? So we'll have a review on Friday after class for class Friday, just like we did with the CAT, and for the the final material, and on Sunday we'll have a review, okay? So far, I mean, most likely it's gonna be from 9 to 10, just like we did the other day, okay? And we will record it and post it for those who were not able to make it. Yes, Melody. Say it again. Oh, after that? No. Well, I'm actually covered all my material for your class, okay? So I covered everything MedChem for you, and then next session you will learn pharmacology. Session after that, pharmacology, another pharmacology. I think there's 3 pharmacology parts that you will learn. So session 2, 3, and 4, you will visit all these topics, but from pharmacological perspective. So my advice to you is keep these notes that I gave you neat and clean, and you could refer to them because you could refresh your mind. In fact, I put all the effort to include everything, including pharmacology, and you try to teach the MedChem component to that, but there's a lot of pharmacology in the materials I gave you. So it's gonna help you. So this session will help you with session 2, 3, and 4, because we will visit all these topics in more details. You'll have to memorize a lot of side effects and all that, but once you understand the basics, then it's just should be easy. Yes, ma'am. For next session, okay, it should be at least a week. You should be able to see the syllabus for session 2, at least a week before the course starts, which is by next Monday. Okay, so by next Monday, you should be able to see the syllabus. If not, contact the coordinator for that session, because you should be able to know the exams and study for the material, because it's going to be session after a session. There's no break, right? After the final, next Monday immediately will start next session. Kendra? Well, that's not an issue. I mean, I can always make it available. It's just, you know, I mean, it's better to save it, of course. Yeah. Yeah, so if you would like to save, instead of going to Canvas, you could save the material in a folder on your computer or return to them anytime. You know, I mean, or if you are missing something, just contact me even after the session. I will be glad to send it to you, okay? So, but I mean, these materials are really should help you for the next 3 sessions. So you could actually refer to them and then use them for, okay? Any other questions? Any questions? All right. Yes, ma'am. Okay. Okay, so who's not at the start screen? Can you raise your hand up high so I can see you? Hi, 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 hi. 1, 2. Can you raise your hand, guys? 1, 2, 3, 4. So, do you think you need a paper copy, or should we wait? Huh? Wait. Do a review. Oh, review for the exam. I see. For the crafts, I know. Yeah, nice try. Nope, not this time. Okay, so Danny and you guys, do you need a? It's just loading. Okay, so let's wait a few more minutes. So in your case, if you want to sit over there, actually, before you go. Structures, would you mind putting them on there so we can see them? Okay, sure. Is that okay? Yeah, sure. You mean for now, for this rat? Just if there's any structures, because I was having a hard time, I couldn't blow it up last time to see it, so I missed one question because I couldn't see the structure and I didn't have to. Oh, I see. Yes, yes, yes. Okay. Just if there's okay. I assume everyone is ready to take the exam. So let me set the timer for you. So you will actually have 15 minutes, okay? No, don't panic. Okay, ready, set, go. Okay, you could start working as a team now. Okay, let's review the questions. Okay, and the first one, what kind of interactions are the most important or most significant? We all know it's hydrogen bonds. It's actually, you can tell all these dotted interactions, all of them are hydrogen bonds, okay? Yes, Melody? Sure. Now, which one of them is really, really, really the most important among all of them? We know all of them are hydrogen bonds, but when there's one of them that is important for the activity. If it's lost, the activity is lost. The other ones can reduce the activity, but then there's one of them, it is, if it's covered, C21, okay? Everybody agrees? Okay. And then selectivity to beta-2 adrenergic receptor is dose dependent, and thus it can be lost even when a drug is administered at higher doses. Well, no, it's true. Can you give me another example that is similar to this when the drug is selective, but then in the higher doses selectivity? Say it again. Phenytoin, okay. So at higher, so we're talking about selectivity. Right, right. So there is another class of drugs that we learned, beta blockers, beta-1 blockers. Remember, guys, in last class, we learned that beta-1 blockers, the selective ones, they should not block beta-2. But if you increase the dose, they will block both 1 and 2. The same applies here, okay? So beta-2 selective, in this case, they are agonists, not antagonists. So beta-2 selective at the given, the right dose, they are selective, but then if you give them at higher dosages, they can still bind to beta-1, okay? So what happens if they bind to beta-1? The heart, the rate and force gets higher, so you get high blood pressure. You get, you feel like your chest, your heart is like pumping, okay? Everybody get that? So that's what it means to be dose dependent. Okay, this is the challenging question for you guys. Right. Okay, hopefully I'll be able to remove the confusion, because every year I get the same comments, and then, and then I do a good job explaining the question, okay? Okay, so esterifying glucocorticoids. Most of you know that adding an ester group would increase lipophilicity, right? Because this is what we have seen so far. All the examples we have seen actually about where ester groups to increase lipophilicity, صح? I mean, is that true? Okay, so this is lipophilicity, and then which causes increase in the duration of action. So how can you decrease lipophilicity if you add? We already know the answer is D, all of the above. How can you decrease lipophilicity if you add an ester group? You could add an ester group, but it's instead of being attached to a lipophilic chain, you attach it to a polar group, like phosphate group or highly polar hydrophilic group. Okay, so let me remind you what is an ester group first. So an ester is anything that has, so let's say this is a drug, okay? Okay, and then an ester is any group that has C double bond O, I'm sorry, that has oxygen, C double bond O, and attached to an R group. So depending on this R group, you could increase the lipophilicity or decrease it. Okay. Sounds good, guys? And in the notes, I'll show you. Yeah, thank you. If you look at page 11, we have a title that says estrifying using blah, blah, blah to increase lipophilicity. And then we have estrifying to increase hydrophilicity. Okay, so making that drug more polar. And then we have examples. In these examples, we added the R group was lipophilic, basically, a chain of carbons and hydrogens. In this example, we added a phosphate group, or it could be a succinate, which is another polar group. Okay, make sense, guys? So that's why using an ester group will help us solve a lot of problems. If you need the drug to be more lipophilic, just to cross the gut wall, then you could esterify the drug and make the R group lipophilic. Then you solve the problem, and then once it's inside the blood circulation, it's converted back to the active form. If you have a problem with the drug being too lipophilic and you want to reduce lipophilicity, then an ester group could be added. In this case, R would be what? More polar, less polar? More polar, okay? This way you'd make the drug more soluble, and then once the problem is solved, it's in the blood, ester is broken, okay? That's why medicinal chemists love the esterase, the ester group and the esterase enzyme, because it helped them solve many problems. You could modify the lipophilicity, hydrophilicity with an ester group, and then rely on the esterase enzymes in our plasma. Everybody get that? Okay, if you got this 100%, can you raise your hand? Excellent. Okay, so in the final exam, when you see esterifying a group, increase lipophilicity, decrease lipophilicity, do not think I'm trying to trick you, because it could do both jobs, okay? Yet, there's still some people who are gonna miss the question, I'm telling you. I do this every year, and I still see people missing the question. Why is that? What? Say it again. I can't hear you. Is that a bonus? For now? Sure, yeah, I'll make it a bonus. I mean, it's... Okay. Just to prove my good intention, okay? No, it's okay. So, you got it, guys? We will see a lot of examples. Well, there's only 2 more sessions, so it's actually a technique that's used very often, where can help us solve many problems, okay, with the pharmacokinetic properties. Okay, next one. Which of these groups is the easiest to esterify? Well, you know, it's C21, okay, which is the same hydrogen that is most important for activity. If it's removed or masked or covered, activity will be lost. But why is C21 is the most or is the easiest to esterify? Say again. It's easy. It's more accessible. It's the easy to access, right? Easiest to access. If you think of these, nucleus and all the carbons surrounding them, will be hard to reach to the OH group here or here. But this one has an arm that extends away from the ring, which makes it easy to access and esterify. So when you make a chemical reaction to esterify the OH, it would be easy to do. Okay, that's the easiest OH you could estrify, okay? And then when you estrify, what happens to the drug? It becomes prodrug. Why? Because it becomes inactive, okay? Have you watched the video? You did? Okay. 2.5 hours? That's a lot, I know. Okay. Number 5. Well, first, any issues with this one? No? Number 5. So, as you have seen in the notes, when we design steroids for treating asthma and COPD, our goal is what? We all know it's all of the above. So we're going to increase glucocorticoid effect. Okay? Why is that? It's the anti-inflammatory effect. Okay? And we want to decrease mineralocorticoid effect. What's the mineralocorticoid effect? The water and salt retention, right? You've heard of the term moon face? Okay, so people who get, I guess too much water inside them because they use one of these mineralocorticoids, they get moon face. It's one of the side effects of the cortisone, okay? The mineralocorticoid. So if they have high blood pressure or they have problems with the kidney, then this is very bad, okay? So our goal is to design the drug in a way to increase glucocorticoid effect, but reduce the mineralocorticoid effect, which is responsible for, accumulation of the water and fluid inside our body. Yes. Oh, nice. Cushing syndrome? I think so. Yeah, I think it's Cushing syndrome. Basically, because of the increase of the cortisone. Yeah. Right. But what's the problem with the glucocorticoids? There's something that comes with glucocorticoids we cannot increase the sugar, right? From the name, that's why actually it's called glucocorticoids, right? Because they increase the sugar in our circulation, which is a problem if somebody has diabetes, okay? They also make you jittery. Anybody try the Midroll dose pack or these prednisone? They make you, jittery and like basically nervous. And so that's why it's better to be taken early in the day, not at night. Okay? And then of course, C, enhance pharmacokinetic properties, make them more lipophilic such that they stay longer in our body and protect them from metabolism, all that. So all the above. There's another side effect of the cortisone, the use of cortisone. Can you name it? What happens to the immunity? It reduces the immunity, right? So you become compromised, or your immunity is reduced, so you are more likely to get an infection, okay? So cortisones should not be used very often because of these systemic side effects. That's why, if you have seen in the case of asthma and the COPD, we take these drugs by inhalation, right? And our goal is to keep them working locally, so they should never get absorbed systemically, okay? Because when they do get absorbed systemically, we have all these horrible side effects of, increase in the sugar, reduction in the immunity, the jittery effect, and for some of them who are not selective, you might get, the swelling because of the mineralocorticoid effect. You got it, guys? Yes, Francisco. Excellent. Thank you so much. That's a very good point. So guys, when we design these products to be inhaled, believe it or not, the majority of them, they will go through your stomach. Only 10 to 30, it varies. Only 10 to 50% of these products go to the lung. The rest, whether you like it or not, they will end up in your stomach. So they are designed in a way such that when they go through the stomach and get absorbed, they are metabolized in the liver. So now the first pass effect is something that we want. It's something to our advantage. Make sense? Okay. So in these products, we want the drug to stay locally. And if they make it to the stomach and get absorbed orally, then we should actually hope that they will get metabolized by the first pass effect and do not make it to the circulation. Okay, Melody? Excellent. Not sure about teeth, but normally when you inhale these powders, you have seen the disc, the discus inhaler thing that comes in powder. Then when you inhale them, then some of the powder will stay in the mouth. So in order to avoid these cortisone staying in the mouth, and they can cause actually some infection because again they reduce immunity. They can cause some problems in the lining of the mouth. So it's better to wash your mouth after you inhale the cortisone. Thank you. Yes. Yes.
So why is it that when it's inhaled, between the time when it's being used and the time when you reach the mouth, it could have been absorbed, right?
Through the stomach?
No,
Through the mouth? Right. Why is it? Okay, so I guess your concern is because it's a fast acting, then when you inhale it, some of the stuff that goes in the mouth could affect, side effect. But okay, but it's not significant amount. So plus those that make it to the stomach should be degraded by the, the stomach first pass effect. Those that stay in the mouth, only like minor amount, so they're not strong enough to cause systematic effect. Yes, yeah, that's a good. Yeah, so guys, the concern here is if you take the fast onset and immediately it's get absorbed through the mucus of the mouth, it could actually cause systematic effect. Yes, but it's minor. Okay, just like when you apply something topically in the skin, some of the drug will be absorbed through that circulation and you have systemic effect, but it's minor. Okay, it's still because it is still topical. The same with the mucus. So I mean, that's a good point. But anyway, do you guys know how these inhalers are structured? How patients should be taking these inhalers? Have you ever counseled someone on taking the inhalers? You did? Huh? Okay, that's after you take, you switch. But how do you? Well, first of all, there are two kinds. Well, the spacer, some people prefer the spacer, or for kids, you want to use the spacer. But you will learn about that in one of the labs, okay? I mean, you will learn about, in the case of the disc inhaler, you want to, break the capsule and then hold it horizontally this way, just like you hold a burger sandwich, and then you're going to inhale as fast as you can. And because it's powder, if you do it this way, you could drop the powder, okay? So you're going to hold it horizontally and then inhale it as fast as you can. Hold your breath like 3 seconds and then breathe out. Anyway, so I want to share a story with you about a customer who actually, they take the inhaler, right? And then they come back. This story didn't happen with me. It's just a story that I read online. So they come back and then you tell them, they tell you this inhaler did not work for me, right? It's just, useless. So then you tell them, how did you use it? I mean, show me how you use it. So they do this, and then, right? And then the next time they get smarter, they said, so I realized, it has to be distributed within a smaller volume. So I locked myself in the car and closed up the windows and then spray it in the air and then smell it. You'll hear like funny stories. So it's serious. I mean, many people don't know how to take the inhaler. So make sure you counsel them, okay? Do not ask them, do you know how to use it? Yes or no. Ask them, show me how to use it, okay? Or sometimes they just inhale it and exhale it back, because they should take the first puff, hold their breath for 3 seconds, and then exhale, and then they have to wait 1 or 2 minutes before they take the second one. With the albuterol, you take 2 puffs, So you should wait for like 2 minutes to allow the drug to be absorbed. So you will learn about all this. I just wanted to share with you this funny story about importance of counseling, okay? Okay, so let's see, question number 6. Beta agonists are resistant to MAO and COMT enzymes, will have longer duration of action. We all know that's true. I mean, generally, if you block metabolism of a drug, you could have a longer duration of action. And then number 7, which statement is most correct? Hydrophobic pockets in the muscarinic receptor are used to design anti-muscarinic agents that do not allow transfer of the signal. That is true. In fact, if you remember the design of agonist and antagonist, what do they call these regions that are next to the binding sites? Extra binding regions, okay? So again, you cannot separate what we learned from basics before CAT2 from this material because it's, you know, just it all come in one. And then the second part, or B, antimuscarinic agents block cholinergic bronchial constriction, thus allow adrenergic bronchial dilation to take over. Remember the balance between the sympathetic and parasympathetic? Okay, so one way to get the sympathetic is to give an agonist like beta agonist. Another way is to block the parasympathetic such that the sympathetic effect will take over. Okay, so you will see antimuscarinic agents that are used, such as ipratropium, okay, to be used for asthma. Now, these antimuscarinic agents, why do we use them if they have such a horrible side effect? We know the antimuscarinic side effects, right? Or also known as anticholinergic effect, right? Can't, right? Can't see, can't be, can. So how do we use these? I mean, locally. Excellent, thank you so much. Because they're given locally, again, they only affect the lung, but they never get absorbed. They don't get systemically. They don't get into the circulation, and they do not produce all these horrible effects, okay? And then the C, increase in lipophilicity will give you a longer duration of action. Of course, we'll know that. So the correct answer is D. Yes. This one, 7? Okay. Okay, so if you find 2 of them that you are sure are correct, then that's easy. You should select one. Yeah, but most, okay, well, I always ask most correct, right? So I always say, you know, most correct for all of them, because when you do that, you know, I can argue with you. You can then, if I don't be like, you know, this is correct, you like, by then I tell you what's the most correct. So it still applies here. I mean, don't you think that all of the above is the most correct among all of them? You're looking for a bonus question, right? Any other issues with this one? Huh? Okay. Well, that is one. D is one. Okay, so your recommendation is if all of the above is one of the options, then just remove most correct. Just say, and then when you see it, you know that the answer will be all of the above. All right. Nice try. All right, here's another try. Go ahead. Yes. Seriously? This is what I hired. This is why I got hired, to confuse you and mislead you. My first class in medicine and chemistry, I had a doctor who actually had options A, B, C, D, E, F, G, and then all of them like A, B and C, D and D. So by the time you get down there, you forgot what's going on. All his questions were like that. Anyway, so, okay, I actually noticed that with the cat too, because it had like A, B, C, D, E, I think it was more tricky. So with the final, I promise I'll stick with A, B, C, D, okay? All right? So I'll stick with A, B, C, D, but then, thank you. Okay, but then, you know, I'm not gonna change most correct, okay? I'm still gonna see most correct. And they're gonna see some of them says all of the above, okay? All right. Number 8. Okay, so this is a game, right? I mean, you are given a table, which you will be given the SAR and the table. All you have to do is just, you know, use the information, play the game, and find the answer, right? So what is the answer? So we all know it's C, okay? So your goal is to actually find which one of these are the R1, R2, R3, R4, R5. In this case, we only care about R3, R4, R5. So R3 is here, right? This is R4, and R5 is actually a hydrogen, okay? Once you find that, then it's easy. 1, 2, 3, which is direct, okay? See. Okay, last one. What type of receptors do glucocorticoid receptors belong to? Well, no, it's the nuclear receptors, okay? So remember, nuclear receptors, they stimulate the synthesis or inhibit the synthesis of proteins. In this case, what do the glucocorticoids do? What do they stimulate or inhibit? What do they do? They stimulate the synthesis of lipoprotein C, which inhibits the enzyme. Yes. What is the name of the enzyme? What is it? Phospholipase. It inhibits the enzyme at the beginning of the reaction, so it's actually more effective than the NSAIDs. Next lecture, we will learn about the NSAIDs, okay? The mechanism of action for the non-steroidal anti-inflammatory. They actually block only one of these reactions, the COX enzyme, okay? But they do not block the others. This one here, the steroidal anti-inflammatory, they block the reactions right from the beginning. So they stop any inflammation, any, these chemicals that produce reactions, allergies, and things like that, okay? Which is why these are more effective used in COPD and asthma. Yes, sir.
Are there any questions that you would possibly, I mean, you never are going to make us differentiate between an intracellular receptor and a nuclear receptor, are you?
In terms of what?
Like
examples?
Like, or something like, if you had written this question, is it a nuclear receptor or an intracellular receptor? I would have been like, well, I know it's one of those two. But I don't even know if all textbooks would even be like saying the same type definitions. But I know things that go into the cell either A, affect molecules that go into the receptor, or maybe B, go directly into the nucleus. I'm not even sure if that mechanism exists, but I just...
Okay, so actually intracellular receptors are not defined as a class. Nuclear receptors are defined as a class of receptors, but they are, they are located intracellularly. That's the whole thing. So some receptors are membrane bound, others are intracellular, right? So the nuclear receptors are the only one I can think of that are intracellular. Enzymes are intracellular, but they're not even receptors. They are enzymes. Okay. Okay. Any questions so far? Yes, ma'am. Say it again. Okay. Remember in like the first few lectures, we talked about the type of receptors. Some of them are membrane bound, like the ion channels, like the GPCRs. Okay. Some of them are located inside the cell, not at the membrane, inside, and they're actually in the nucleus, inside the nucleus. So these are one of the receptors that are located inside the nucleus, and when they are activated, they go to the DNA and RNA and stimulate or inhibit the synthesis of protein. Okay? Right, any questions so far? Okay, I assume you need a break and come back fresh. Right, so let's take 7 minutes break and come back.
When you put this question on exam, it doesn't show the structures.
Okay, I'll print them. I'll print
Hey guys, hello. For those of you that have not signed the professional pledge, I was told there were a couple of you. If you could get that done today, that must be done because we are, I guess, reading that tomorrow at our, what is the thing? Yeah, the banquet dinner tomorrow. Thank you. So yeah, if you could make sure that you go up to Miss Krimmer's, I believe she's on the 3rd floor. Yes, she's on the 3rd floor. So please go see her today. Thank you.
Okay, guys. So in the first exercise, you're going to use the table that in the note to differentiate between glucocorticoids versus mineralocorticoid selectivity. Basically, your goal is to design one that has the highest anti-inflammatory effect with lowest salt water retention effects. Okay, so use the table to design one that has this feature. Each one should have an example that they're going to share with us. Okay, we're going to call teams and have them represent that. In the second part, you're going to design one that has a long duration of action, and on the third example, you're going to design one that can be given through IV administration. Okay, so would that be lipophilic or hydrophilic? Hydrophilic. Okay, so use the table to answer these 3 parts. Now remember, the table will be given to you at the final exam, so you don't have to memorize it. You just have to know how to use it. Tahrir, you have a question? Yes, I'll do that at the end of the lecture. Yeah, yes, yeah. So we missed 2 applications from Friday class. So when we finish early today, we'll visit them. Okay. Right. So go ahead and start doing that. Hopefully, let's set 5 minutes. You should be able to do it in 5 minutes. If not, we'll give you more time. Okay. So at 10:26, we'll discuss. Yes. The table is in page 8. Okay, page 8. I assume you guys need more time, right? Okay. Now remember, what's our reference in comparing between the glucocorticoid, mineralocorticoid activity? There's a reference, there's a drug that we use as a reference when you compare hydrocortisone, okay? This is the natural molecule in our body, so we use it as our reference. So when we compare drugs designed, we say, you know, it has higher glucocorticoid activity or less mineralocorticoid. Hopefully, the goal is to make the mineralocorticoid activity zero, not just reduced, okay? Because some of them has less, but then when you have zero is the best. Yes. guys ready now? Ready? Yes? Okay. So any volunteers? I would like to have some, at least like 2 teams on each example, just so you guys cover the most. And by the way, the way I've been trying to use this table, I found the easiest way is to disregard the triangle, the square, circle, closed circle, and that, because it's confusing. The easiest way, just go by the numbers, okay? So you have the nucleus, it's numbered already. All you have to do just use these numbers directly, but it's up to you. If you like to use the squares and triangles, that's up to you. Okay, any volunteers? No? Okay, use my random number generator. Yes, Melody, right. Team number 12, yay.
I don't know how to zoom out. I don't know how to zoom out on this one. Sorry. Oh. Oh, there's on one. Okay. Is it on? Okay. Okay, so for part, are we doing A, B, and C? Yeah. Yeah. Okay, so for part A, we went and added an OH at position 11 to increase glucocorticoid. We put a double bond at position 1 right there to increase glucocorticoid. We put a fluorine at 6 to increase glucocorticoid, and a CH3 at 16 to decrease mineral corticoid. Is that it?
Yep, thank you so much. So guys, if you look at the table, so if you follow these substitutions, they're going to increase both anti-inflammatory and the mineralocorticoid activity, which we're not interested in. We're interested in increasing the anti-inflammatory effect and reduce the mineralocorticoid effect. So you want to apply these and at the same time apply that, as long as there is no conflict, okay? The only conflict is with at position 6. If you add the fluorine at the alpha position, then you cannot add CH3. So you could do the one of the other. And then you could actually enhance the molecule by including as much as you can on, on both sides. All the drugs you have seen in the notes, they follow this table, this table, the SAR table. So you could check the drugs for yourself and see how the activity enhances, okay? Okay, do we need to get another example on something that has more glucocorticoid and less mineralocorticoid? No? Okay, move to part B. Okay, so let's see another example. An example on part B, which is increased duration of action. Any volunteers? Any volunteers? Team number 5. Team number 5. You're going to share with us an example on a drug that has high lipophilicity, which means it will have a longer duration of action. Is team number 5 here? You want me to skip? Yeah? It's okay. I'll give you a break. Sure. No problem. Team number 17. Team number 17. Well, for your information, team number 10 wanted to volunteer. You guys want them to do that? Yeah? You want to pass? Or you want to do it? Pass, do it. You guys decide as a team. Pass. Okay, team number 10. Come on in. Yay.
Because I volunteered this, so why not? For B, in order to have a longer duration of action, it said that in the reading that when you add a bulky group to the C21, that you increase the duration of action. So we added the T-butyl to the C21 to increase the duration of action.
Excellent. Very simple. Thank you so much. You could also choose from this table, guys, as well. All these are examples on increasing lipophilicity. Notice that, and here's the other examples. So in these examples, they esterified the OH group on 21 with all these ester groups, lipophilic groups to increase lipophilicity, okay? Here, they actually added lipophilic group on 2 or even 3 of the OH groups, okay? So these are even more lipophilic, okay? Increase the lipophilicity further, okay? I'm talking about these 2 examples. So any of these examples would actually be okay to increase lipophilicity. Now you could increase lipophilicity as much as you want, and then, you know, this would increase the duration of action, okay? Well, I'm sure there is a limit, okay, but because the drug has to be absorbed at some point to get through the lung. Now notice that in all the cases, anytime you mask or you cover, you know, you esterify the C21, the drug becomes prodrug, okay? The only case where the drug remains active is this case, okay? So you should be able to look at the structure, check the OH group at the 21 and decide if it's a prodrug or an active form, okay? Of course, in this case, since we used the C21, so all these would be prodrugs, okay? Okay, and let's see part C. We need to add something that is hydrophilic. Any volunteers on part C? Yay, team number 15. Come on in. Thank you.
Okay. So we just added a hydrophilic ester to make it more soluble for IV. That's all.
Excellent. Very simple. See? And again, in the table, you have 2 different groups. You could add succinic, sodium succinate, or the sodium phosphate. These are polar groups. So again, we're esterifying, we're using an ester group to reduce lipophilicity, okay? Now, notice that we want the drug to be more polar in case we need short, fast onset, or if you are administering the drug by IV, okay? But if you need a long duration of action, then you could give the drug, you make it more lipophilic. Any questions so far? Any questions, guys? No, so when you see the table, you'll be able to use it, okay? Good. And you'll be able to tell which one is a prodrug, which one is not. You'll be able to compare between them as far as lipophilicity, which one has a longer duration of action, right? And which one can be given by IV or not. Which ones can be, what else? Has more glucocorticoid effect or not? Any questions? '21, yes. Yeah. So the only OH group that if you use to esterify or remove or cover, it becomes a prodrug is 21. Okay. Now there are two exceptions, which are and I'm not talking about esterifying, but if you replace the OH group here with chlorine, or if you replace this whole part with an SCH2 fluorine, then the drug remains active for some reason, okay? Say it again. For these two, you can use them topically. Is that what it says? I can't remember now. I'm sorry. So if you substitute the C21OH with any of these two groups, these are exceptions. The drug still remains active, okay? So I think, so I'm not sure, if, I believe they increase the lipophilicity, so they can still be used for long duration of action and topically, okay? You need it more, John? We're fine. There are two more examples on prodrugs that do not rely on the OH at position 21, but rely on another something else. Have you seen this? I mean, have you studied this metabolism? So this drug here, I mean, this molecule is naturally in our body, okay? And there's an enzyme that converts converts the hydrocortisone to cortisone. The enzyme is present in the liver, and it's called the 1-beta hydroxysteroid dehydrogenase. Okay, this is page number 9. I'll give you a minute to open the page. So this shows how hydrocortisone is metabolized in our body, okay? So all these structures are actually inactive, okay? The only active form is the hydrocortisone. Now, cortisone is another drug that could be used, right? You've seen, drugs, cortisone in the pharmacy. So it's inactive when it's given the same enzyme can convert the cortisone into hydrocortisone, right? So if you have more of the cortisone, then the equation will go the other way to balance having both cortisone and hydrocortisone. So this is an example of a prodrug cortisone. What happens is actually at position 11 here, OH group, instead of keto, it should be OH group here. So this would be inactive and it's converted into the active form. A very similar example is the prednisone and prednisolone. Okay, so prednisolone is the one with an OH here at position 11. Prednisone is the one with the ketone at position 11. And I believe the only difference between hydrocortisone and prednisolone is so between these two, the difference is the double bond here. So the double bond at 1, 2. So this is 1, this is 2. Adding a double bond here. In other words, removing hydrogen dehydrogenate this bond would make it prednisolone, and it would increase its glucocorticoid activity, okay, as we have seen in the table. And then prednisone is simply the ketone group of this, okay. Which one is available in solution form? Which one is available in the tablet form? Prednisone is in the tablet form. Prednisolone is in the solution. Okay. So it's about, so you could choose, the one that, they are selected for formulations. So prednisolone is formulated actually in alcohol. Okay. So if you have liver problems, which one should you take? Huh? Prednisolone, because it's the active form. Prednisone is inactive, okay? It needs the liver enzyme to convert it into the active form. Everybody get that, guys? Okay, so if you have liver problems, you do not have the enzyme responsible for converting the prednisone to prednisolone, then which one would you choose? Prednisolone, the active form. So prednisolone is the active form, prednisone is not. The same with the hydrocortisone and cortisone. Hydrocortisone is the active form, cortisone is not. Okay, so if you have liver problems, then you should go with the active form, not the prodrug. So I would avoid cortisone or prednisone. Okay. So you guys have seen also how the tapering off of these cortisones, right? When you write a prescription, for example, in the mid-roll dose back, you go like 6, 5, 4, 3, 2, 1. And with the prednisone, you would see 12 days dose back or 6 days dose back. That also goes in a similar way. You take like 12, 8, and then you go down. Why do we do that? Huh? So why in the case of these prednisones or cortisones, we use the taper off of the dose? We go down gradually. Yes? You don't what? I'm sorry? What do they do to the HPA? Excellent. They inhibit. So when your body sees that you have too much cortisone, they stop. They have negative feedback to the HPA axis, and they stop the synthesis of the cortisone. Okay. So why do I have to taper down these drugs? Exactly. So if you stop the cortisone suddenly, then your body will be out of the cortisone. So what you do is you're actually stopping gradually, to give the body the time to synthesize these cortisons. So why do we not do this with the other drugs? What's so special about cortisone? It's just the nature of the HPA axis. It's just very lazy, right? It just slow pathway that it takes it time to realize that, oh, I better make cortisone, okay? You know, with some drugs, you might be able to just stop the drugs suddenly and that should be fine. But in these cases with the HPA axis, it actually takes it time to realize that, you know, I'm out of cortisone, I better start synthesizing the cortisone. If you don't, then you have, you know, disruption and the synthesis of protein and metabolic, you know, pathways and horrible side effects. So that's why we like stop the cortisone gradually. Everybody get that, guys? Okay, before we switch to exercise number 2, any questions about this portion of the steroids? Let me get just 1 or 2 questions just to be safe. Yes, John.
What is the name of it when you don't taper? Is there that?
You don't, if you don't, what side effect it gets?
What is, I mean, I think it's in the reading. I just, off the top of my head.
Are you referring to the HPA axis? No?
Right, whatever, is it a?
Well, this is,
hypothalamic, I mean, is there some name for it? Like
I'm not,
crisis or-
I don't remember any. Was there any? That's all, just withdrawal symptoms. But I'm sure there are some side effects that should be defined in if you stop these cortisons suddenly. I can't recall.
In the notes for it,
I don't remember.
but
I wish I
I
remember.
don't remember enough to be sure that I was giving that question.
Yeah, that,
Otherwise I would miss it.
yeah, any other questions? Let me take one more just in case. So you got everything we have talked about, 100%? Raise your hand. Okay, excellent. Okay, so in the next exercise, we're going to do something similar, except now we're going to talk about beta 2 agonists, okay? So we're going to design ones that have direct, indirect, or mixed, okay? Actually, you want to skip this part because it's just direct. You want to skip this part A? No? Yes? Okay, well, let's do it just in case. So we're going to design one that has a direct or indirect or mixed, and then you're going to design one that are selective to alpha, beta, or beta 2 receptors, and then the duration of action as it's affected by metabolism. Okay, design one figure. Okay, oh, we are not designing a drug. Okay, I get it. Okay. So I think the goal of this exercise is to summarize everything in page number 18, as well as I think there's something else. There's another part with that we talked about the. I think mainly 18. Anyway, so try to summarize this writing in page 18, okay, with one figure. So draw the structure of the norepinephrine and then write everything in the notes in terms of structure. So, you know, position here, there should be OH group if it's direct, indirect. Certain positions here, if we block, then we could actually increase duration of action and so forth. Does it make sense? So it's like trying to make a cheat sheet in one you know, small page in one figure. John?
Okay, what I was asking, what you had on there was hypothalamus pituitary adrenal suppression. So that was the thing I looked at.
The term, okay, the HPA suppression.
That's what was in the notes. That was
But not, okay. Thank you. Yes. Mhm. Guys, just like the table you have seen with the glucocorticoids, where you have one structure and then summarizes everything, try to do the same thing for beta 2 agonists. Make sense? You look confused. What is it?
I took the instructions as kind of like make a drug that has like one or the other. So we made like a direct, and then it has beta selectivity, and then we increase. Is that what you mean?
Yes, but this covers only the direct and indirect and mixed. You should also add the other information that talks about, you know, the MAO count. Yeah, something like that. Yeah. So like make a table, just like the table we have for the steroids, list all the options and all the possible function groups, and then use that. Well, maybe if I tell you what's the goal of this exercise, it'll make more sense. Okay, so in the exam, would you like to be provided by this page number 18? Or, wait for the second option, or you could summarize this page in one table, and then you could use that in the exam. Which one do you like? Okay, how many of you would like to use the page by itself? Okay, how many of you would rather summarize it in one table and use it? Okay, you don't trust your work, do you? Okay, fine. So summarize this page, and then we'll give you this page in the exam, okay? I'll print it for you. Yes. Sure, if you change your mind, you could do that, yes. So, you can work as a class. If you decide to, the majority of the class, if you decide to use something summarized, then yes, we can do that, okay? Okay, so hopefully in like 5 or 10 minutes, we'll look. Do you need a break? You look sleepy and tired. Okay, so take 7 minutes break and come back, and then we'll finish exercise number 2. Okay, guys, so take 5 minutes. Take 5 minutes and start working on the exercise number 2. It's not funny. Yeah, I was holding this. So guys, these notes here are already summarized by this table. So do not waste your time summarizing these because it's already in here. Your goal is to summarize these, the changes on R1, R2, and the ring, and how these 3 changes affect selectivity and how they affect duration of action and stability, metabolic stability, okay? Are you guys ready? Yes? No? Ready? No? Need a few more minutes? Okay, so maybe until 11:25. Okay. Okay, I assume you're ready now. Okay, any volunteers? Any volunteers? Francisco, thank you so much. Coming in. Team number 2. What do you want to do? It's up to you. Well, do you actually, so you could show them this or no?
No, I guess it would be better.
Yeah. All right. Thank you, team number 2.
The R3, R4, and R5 all play a role in deciding whether the drug will be direct, indirect, or mixed in their mechanisms of action. If there's an OH at R3 and R4, it's going to be direct. And our R1 group determines the selectivity to alpha or beta receptors, and R2 substitution other than a hydrogen will increase the duration of action, makes it resistant to MAO metabolism.
Okay, thank you so much. Thank you. Okay, so how does the size of the group attached to R1 affect the selectivity between alpha, beta 1, beta 2? When it's hydrogen, what happens to the selectivity? It's non-selective. It binds to alpha, beta 1, beta 2, right? When it's methyl, gets more selective to beta. Isopropyl, even more selective to beta. What happens when it goes to bulky, like the butyl group or the aralkyl group? It becomes completely selective to beta 2. Okay? So this is as far as R1. And then as far as R2 is concerned, why is it that when we substitute this here, if we substitute hydrogen with an alkyl group, for example, methyl or ethyl, then it becomes more stable? Why is that? it become resistant to the MAO enzyme. Remember the monoamine oxidase enzyme? Okay, it's the same enzyme here that metabolizes this part. So when you add a bulky group here, what happens? Huh? What happens? It becomes more stable. It's more metabolically stable to the MOA, but why? You know what a steric hindrance is? Steric hindrance. So adding a bulky group will prevent the enzyme from reaching to the site where it needs to work. Okay, so a bulky group would actually occupy the region and then prevent the enzyme from being able to attack the group. Okay, you guys are so sleepy today. Let's see. And then it also says if an ethyl group is used as a bulky, then the selectivity for beta 2, besides having a bulky group at nitrogen, will be enhanced. So, specifically if you use an ethyl group here, okay, at the R2, and having a bulky group, then becomes even more and more selective to the beta 2. But let's talk about the ring, okay? So these 4 examples are the ones that will make the ring selective, will make the drug selective to beta 2, okay? So any of these rings will make the drug beta 2 selective. Make sense? So by experiments, if you look actually at all the drugs that are selective in this chapter, you will see that they fit some of these rings. I mean, it's going to be one of these 4 if they are selective to beta 2, okay? There is something else that talks about the resistance to being metabolized by the COMT. What's a COMT? Catechol O-methyltransferase. So what is catechol? Exactly. When you have an aromatic ring with 2 H group next to each other, this is a catechol group. So the enzyme identifies the catechol group and then methylates it. It adds a methyl group. So if you modify this group in any way, it's no longer catechol. So the catechol enzyme, COMT, will not be able to metabolize it. What happens to the duration of action? Longer. Okay? In fact, if you check all these groups, this one is not catechol. Why? The OH group should be next to each other. They're not. This one is not. Why? Because we have CH2 and then OH. Okay? And this has different group. This is not even a catechol. Make sense? Yes, additional. Page 17. Okay. Mm-hmm. Mm-hmm. Yes. Catechol. Yes. Yes, it would, but the meta position is more important. So as long as you have one OH at the meta position, you're still able to bind and give the activity. Yes, if you remove that and you keep only the para, you check the table of the direct indirect action, it will become inactive. Okay, so that's a good question. So if you look at this interaction, you might think both are important, but experimentally, testing, removing one and test the other, I was found that the meta position is the one that's essential for activity. If you remove it, you lose activity. If you keep it, if you remove the other one, the para, then it's not. I want to prove this to you here. R5. Let's see. R4. Okay. So you have a direct effect from R4, which is at the meta position, okay? R5, which is at the para position. Optimal if you have both OHs, but if you remove both of them, you'll have indirect effects. So you could still have some effect, but it's indirect because it either prevent the uptake of norepinephrine or, like inhibits the MAOA or something like that. Okay, that's a good question. Any other questions so far, guys? So you'll be able to use this information. Okay. In fact, these two SAR exercises cover all the other drugs. That's the only thing you need to know. Okay. So as far as features, metabolically stable on that, I don't care about how much activity is enhanced. You will see that it's like 5 times or 11 times. You don't have to worry about that as long as the activity is enhanced or decreased, just being able to compare. Okay. And don't worry about the other things, that side effects or formulations that these drugs are available in. Make sense? Any questions so far? Okay, so the last exercise actually is something we have seen when we talked about the anticholinergic, right? So we already know the structure of the acetylcholine, and we already know how it binds to the receptor, but we want to bind to the receptor yet block the receptor. Okay, so in order to do that, so this is acetylcholine, this is the receptor, okay, and we have extra binding regions outside, or that they are not being used by the acetylcholine. So we used these hydrophobic pockets to design drugs to bind to these extra binding regions and block the receptor. And guess what? When you add these hydrophobic groups, what kind of induced fit will you get? Is it the same as the acetylcholine? It's going to be different induced fit, okay? So you'll have a different induced fit, which is your goal because you're trying to design an antagonist here. And we're not worried about, again, we're not worried about the side effects of these anticholinergic drugs. Why is that? Like Kevin explained earlier, because they're given locally. These are inhaled. So they have only minimum amount of that drug will be reaching the circulation. So we're not going to see these side effects. All right. Is this better? Okay, and I will post this on Canvas. All right, questions? Yes, ma'am.
Whenever you were going through the ring,
Okay, questions? Melody? Oh, this part, exercise number 3. So remember when we talked about the design of antagonists, and we said our goal is to look for extra binding regions in the binding site and use those binding regions to make the drug bind to them such that hopefully the resulting induced fit will be different than the induced fit of the natural molecule. So that's what we're trying to do here. We have acetylcholine. We know how it binds to the receptor. We have some extra hydrophobic regions, pockets, and we used these extra binding regions to design drugs. And indeed, the resulting drugs have produced different induced fits, and they were working as antagonists. So they were actually blocking the receptor and not stimulating it. So they have anti-muscarinic effect, okay? Questions? This is depressing. What's going on? Just tired of this session? Too much? I know, it's too much on me too. But I hope you learned. I mean, yes, Kendra. See, for your class, the curriculum was designed differently, so we are covering all the basic sciences. So I actually covered everything MedChem in this session, and then you will learn, you will get all pharmacology concepts covered in session 2, 3, and 4. And then after that, you're gonna have some basic sciences like pharmacokinetics, and then clinical. Then it's gonna be rest of, clinical, gonna see clinical faculty, and starting, year 2, more like second semester of year 2 until, 3 years. They finish the 3 years. So the first year and a half about basic sciences, another year and a half clinical. Okay. Yes. Yes. So the short answer, yes. You're not gonna be bothered by me again. Kendra. Okay. Okay. Who do you talk to? I don't think there's anything you can do, because it's just the way the curriculum is set up, and just. I'm sorry. Say it again. Oh yeah, it did. Yeah, but not for for each class year, the curriculum would change just one time. We cannot change it. Next year, we're gonna have different curriculum, and it's gonna be anyway. I'm not concerned, but I'll be in my office. You can always stop by and say hi and ask questions. Seriously. I still have students who come ask me from other classes. I try to be, safe not to say something that I'm not sure about. But so yeah, you can always stop by. Other questions? Any questions about this material, guys, so far? Okay, so I was gonna go to the last 2 exercises we had on Friday, but before I do that, are you sure everything is clear so far? Okay, so let's go to that exercise that we left. I know you need a break, so I'll make this very quick. Like in 10 minutes, I'll cover the concepts I want you to know for sure, and then we'll move on. I mean, you can take the 10 minutes break and come back for a review. Let's see. So this question was talking about the intrinsic sympathomimetic activity drugs, the ISA drugs, okay? And then we wanted to talk about the advantages over the rest of the beta blockers, okay? So how these ISA different from the rest of the beta blockers? And as far as efficacy, they have less effect. They're actually what? Agonist, antagonist, they're partial. So they're partial agonists, okay? So in case you wanna reduce the blood pressure, but you do not wanna drop it really low, then you could use cases like that. Also, in case you wanna give a beta blocker that does not have the side effects of, anti-diabetes and people with asthma and all that, then you could use something like that. So these are the advantages, okay? So think of, instead of, blocking the beta receptor 100%, you could block it just enough to bring it back to normal. So this is for people who have their blood pressure not really high, just high a little bit. So you could actually go with the ISA, Okay, they're called intrinsic sympathomimetic activities. So can you name the example of these drugs that has intrinsic sympathomimetic activity? No, because you're not supposed to memorize, right? Good. Okay. So yeah, so it's okay, but you will need to know this later on. Okay. So, but I will let you know that this drug has a sympathetic, has ISA activity, and then you will see questions about that. Okay. Okay. What else? Also, for later on, you also need to know the drugs that are beta-1 selective. Okay. I do remember using some acronyms. If you could find like the first letter of each drug and make a term to help you memorize, these things can be helpful. Yes. So don't memorize examples on the selective or the ISA, okay? So I will provide you with that information. You just need to know what it means to be selective or not, okay? Sure. And then exercise number 15, what is the rationale behind selectivity of beta-1? So when we design drugs to be selective for beta-1, how did we do that? There's only one figure that explains it all. Remember this? So beta-1 receptor has this group here that can form hydrogen bond. Beta-2 does not, okay? So we use this function group here to our advantage. If we make electron acceptor group at the para position, it can interact with this one. This way, we can give less or more amount of the drug and it would bind to beta-1. What do you think? Less? Yeah? Yeah? I'm saying, so in order to take advantage of the XH group and beta-1, okay, we design drugs and place the hydrogen acceptor group at the para position, okay, such that it can bind to this group. So this is beta-1 receptor. We have this group here in beta-1, which is not in beta-2. And then we have two drugs. One of them has the hydrogen acceptor group at the meta position, which means it's not going to interact. Okay. The other one has hydrogen acceptor group at the para position, which means it can interact with this group. Okay. So now, in order to give one of these, in order to give the selective drug that binds to beta-1, we can actually give it in a small amount. Why is that? Because we know it can form hydrogen bond with the beta-1, but not beta-2. And then I'll be able to, block beta-1 receptor, but not beta-2. Try to think of a better example. Okay, so if I know that beta-1 receptor is able to form hydrogen bond, but beta-2 is not, then I can provide this feature in the drug and then give only small amount of the drug, because I know although it's small amount, it can still use or take advantage of the hydrogen bond in beta-1. And then this way, this small amount of the drug will not be enough to bind to beta-2 receptor. Does that make sense now? Excellent. That's why if you give more of this drug, okay, if you give larger amount, it will bind to beta-2. It's dose related, yes. So it's dose dependent. Thank you. So which receptor is able to form more interactions, beta-1 or beta-2? Beta-1. And because it can form more interactions, I can administer smaller amounts or larger amounts of drugs. Smaller amount, okay? That's the trick. This is the rationale, okay? So I can take advantage of the larger number of interactions and design a drug and give only small amounts such that it will be enough to bind to the beta 1 but not beta 2. Okay? Make sense? You got this 100%? Raise your hand. Okay, excellent. The last point I want to talk about here for this part is diabetes. So as you know, people who have diabetes, they are more likely to have hypoglycemic effect. I mean, hypoglycemia. Why is that? You know, diabetes means high sugar. So why would I be concerned about hypoglycemia? Insulin. So when they take insulin, what happens? Hypoglycemia. So why? So let's say that they ate something and they thought they had this amount of calories. They did the math and they took insulin, but apparently the food they ate did not have much calories or glucose. So the insulin was more than what they needed. So they get into hypoglycemia, right? The same with the medications. If they take metformin or the secretagogues medications, then they assume that they have, you know, constant amount of glucose taken daily, but because it's hard to control the amount of food you take every day, then you might run into cases where you get hypoglycemia, right? And then if they have hypoglycemia, what happens? They faint. They can, you know, pass out. Okay. Make sense, guys? Okay. So those people with diabetes, they are trained to monitor certain, I guess, certain signs. There are certain signs that they watch for if they have hypoglycemia, and that's why they always have, you know, glucose tablets, rapid dissolving glucose tablets with them, just in case if they feel these signs. To avoid having hypoglycemia, what they do, they take these glucose tablets. Okay, all right. With this introduction, what are the signs of hypoglycemia before, you know, you actually faint? Sweating. What else? Tremor. Tachycardia. Heart palpitation. What else? Huh? Confusion. What else? So all these signs are actually sympathetic or parasympathetic? Sympathetic. Okay, so when you block the beta 1 receptor, what happens to these signs? They go away, right? They disappear, except for the swelling. Why? Because it's mediated through acetylcholine receptors. So guess what? If someone has diabetes and they're trained to watch for these signs, and now they take beta blocker, you should advise them that now they should watch for what sign? Sweating. Because all the other signs, tremor and tachycardia, will be gone. Okay? Make sense? All right. Any questions about this? You got this 100%? Raise your hand. Okay, excellent. So take a break and come back at 12, and we'll see if we have any questions about today's lecture. And we might also look at the second part of the anti-asthma and COPD drugs, you know, the thiophanate and all that. Okay.
Hey guys, just to reiterate, the final for this class is 1 week from today, okay? I know some people just wanted a reminder, so, okay? No, just this one. Normal class time, I'm pretty sure. And later today, we have that immunization final test that you get to do twice. So that's at 1 o'clock. Thanks, guys.
Okay, so let's see if you guys have any questions. Vivian, you want to start? Sure.
When you talked about long-acting short versus, we need to notice that's short versus long-acting.
From the structure, yes. So guys, when you see two different structures, whether they are steroids or beta 2 agonists, you should be able to tell whether it's a long acting or short acting, right? So what are the factors that affect the duration of action? Number one, yes. Okay. Lipophilicity. So if the drug is more lipophilic, then it will have a longer duration of action. What else? What do we look for besides lipophilicity? Besides lipophilicity, what else? Metabolic stability, thank you. So in the case of the beta 2 agonists, we had two enzymes that metabolize the drug. What are they? MAO and the COMT. So where in the structure would it make the drug resistant to the MAO or the COMT? Exactly. As far as MAO, we will look at R2 position, right? So R2, if it's substituted by a methyl or an ethyl, then it would be more resistant to MAO, which means it will have longer or shorter duration of action? Longer. Okay. Now, as far as being stable to the metabolism by COMT, where do we look in the structure to see if it's resistant to the metabolism by COMT? We look for the ring, catechol ring. We see if we check if the ring is a catechol or not. If you see this ring, phenyl OH, then it can be metabolized. If you see any of these rings, then it's not able to be metabolized by the COMT or anything else other than the catechol. Okay. Besides, these rings will make the drug more what? So these four rings, besides the fact that they will protect the drug from being metabolized by the COMT, they will make them beta 2 selective. Okay. So what are the advantages of making the drug more lipophilic besides having longer duration of action? Say it again. More localized. What does that mean? Stay in the lung. We will not have no systemic side effect, right? Everybody got that? So advantages of making the drug more lipophilic in the case of the asthma and COPD, as we all know, it will have a longer duration of action. Another thing is it will be localized. It will not be absorbed systemically, which means you will have less side effects, right? What about orally? As we know, less than 50% of the drug stays in the lung. More than 40, more than 50, like the majority of the drug, when you inhale it, it actually goes to the stomach. So when it's lipophilic, then again, it will not be able to cross the gut wall. So you, again, will have less systemic effect, okay? On the other hand, what are the advantages of making the drug more hydrophilic? You could design, you can administer it by IV. So if in case you need, emergency, you need something quick, IV. What else? Duration, onset of action, will have a fast onset of action, quick. Okay. Any questions? Yes. Right. Short. So normally when they have rapid onset, means they are hydrophilic, so they will be absorbed through the circulation and metabolized, so they will have a short duration of action, okay? Yes, this is generally true. I mean, there is some exception, yes. Yes, that's a good question. So generally when you have long duration of action, they will have a slow onset, and the opposite is true. If you have a short duration of action, you have a fast onset. Of course, there are exceptions, but this is the general rule. Yes, Kevin? Sure. Okay, so the other part, guys, the part 2, which is optional for you. So the only thing I really want you to know, as a pharmacist, you should really know about the thiophyllene is that it has a narrow therapeutic window, okay? So this is the optional reading, okay? Remember there are 2 parts, and then we talked about methylxanthine. So the only thing I really want you to know, or as a pharmacist, is that thiophyllene, they actually, they cause bronchodilation, okay? They could use for asthma, but they actually have a narrow therapeutic window. So they are not our preferred, they are not our, best option when it comes to treating asthma. But you will learn about, the options available from the clinicians. So the guidelines you should use, okay? This here simply shows how, the drug binds to its receptor. The mechanism of action is not clearly understood, but there are some suggestions here. What else? They also have many drug-drug interactions. So the thiophyllene has many interactions with other drugs such as, calcium channel blockers, beta blockers, cimetidine, oral contraceptives. This class here is more important, the leukotrienes. So in this pathway. Remember the glucocorticoids. Where does the glucocorticoid work? Right here, phospholipase A2 inhibitors, right? They actually stimulate the synthesis of, what's the name of the protein they stimulate its synthesis? Was it lipoprotein? Yes, I think it's lipoprotein C, lipoprotein C. I think it's lipoprotein, let me check. Oh, lipocortin. Okay, it's just lipocortin. So something called lipocortin that inhibits this enzyme here, and so they block everything here. The leukotriene modifiers, they actually act on the LT leukotriene C4, CDE4. So we have CDE4. So they actually block how these leukotrienes bind to their receptors. Okay. You've heard of single air, guys? Single air. What's the generic for single air? Montelukast, right? So these are leukotriene modifiers. Okay. They block the synthesis of leukotrienes, or they bind as antagonists. Okay. So they either inhibit these enzymes here, such as the LTC4 synthase, and this way they block everything here, or they block the binding of these leukotrienes to the receptors. We had something very similar to that in the past. Oh, the other examples. Okay, we have something called Xylutone, Zyflo. Let's see, receptor antagonist, we have Singulair and Acolat, which is Zephyr-Leucost. Zephyr-Leucost, I'm not sure how they pronounce that. I think there's only 3 examples here, okay? But I was gonna say, remember the example of the ACE inhibitors and the ARBs, right? So the ACE inhibitors, we inhibited the enzyme, but then with the ARBs, we inhibited the receptors. This is very similar to leukotrienes modifiers. Some of them block this enzyme synthase, okay? So they prevent the synthesis of all these nasty products. Others, they block the binding of these to their receptors, okay? Yes.
That's a different enzyme. So we had it just the glutathione, not the synthase. I was wondering what the link was. So we should correct that.
I'm sorry, say it again.
I mean, this enzyme doesn't have a role in it as well. This glutathione. I mean, I was wondering what the link was with that enzyme. Because we saw that enzyme with the nitric oxide. That was the enzyme we dealt with. You didn't have it up.
Oh, it's probably. Is it just your printing, or let me check with other. Well, some of you that was not able to see this link here and you're printing it. Has everyone had the same problem? This enzyme here? Anyway, so I'm only worried about, well, this is like, optional, but I'm only worried about the concept itself. So this is similar to the concepts we've seen in the ACE inhibitors and with the ARBs. You could block one of these enzymes, or you could actually block the binding of these drugs to their receptors, okay? An example of something that inhibits the enzyme is the Xylutone or Ziflo, which is 5-lipoxygenase inhibitor, Okay, it blocks. Oh, here, I'm sorry. It blocks this enzyme. Okay, and an example of the antagonist drugs are the monteleucost and the zafirleucost. So notice that the same concept we have seen with the antimuscarinic. We looked at the receptor and then we look for extra binding regions and then we use these to design antagonists. Okay. And with the case of the zafirleucost, it should be taken on empty stomach for the same reason of the ionization and ionization. Yes, ma'am. Yes, optional. Yeah. Yes. Yes. Okay. You're welcome. So if you have questions, about the other material, feel free to ask me. I'm just using the time to talk about other examples. So other mechanisms of fighting the asthma is, how the histamine, well, you have not learned about the histamine. Next Wednesday, we'll learn about how histamine is actually stored into mast cells, okay? And these mast cells, once they are stimulated, they release the histamine. So one mechanism of fighting the asthma is by stabilizing these mast cells such that they do not release the histamine and the nasty chemicals that cause all these allergic reactions. Example on these are cromolyn sodium and nidocromyl. Looking for some. Okay. And then we have another example. Which is the antibody. So there are certain drugs that interfere with the way how the antibody binds to the white blood cells and stimulate the inflammation. So we have an example of a drug here, which is called the omalizumab. And I believe it's given by injection because it's a protein. Let me check. Subcutaneous administration. Just like with the insulin and all the products that are protein in nature, they are unstable, so they are given by injection. This is like, this would inhibit the antibodies that stimulates further the inflammation. Okay. We also have two examples that are phosphodiesterase inhibitors. In fact, there are many types of phosphodiesterase. You guys heard of the phosphodiesterase enzyme? Has anybody heard of the phosphodiesterase enzyme? Yes? Where? When? Dr. Pearson? Okay. So can you give me an example of a drug that uses the phosphodiesterase enzyme? No? There are actually many kinds, and different enzymes can be used for different functions, okay? So if you look at the notes here, we have like 11 families. 3 of them, phosphodiesterase, 4 are found in inflammatory cells. Okay, so these are the ones that are targeted in this case. But then we also have, I don't think other examples are listed here. But we also have other examples that would cause vasodilation, like the nitrates. I think it's phosphodiesterase 5. So guys, if you inhibit certain phosphodiesterase, you can actually produce different effects. If you inhibit phosphodiesterase 4, you get anti-inflammatory. If you inhibit phosphodiesterase 5, you get vasodilation, okay? Do you guys know how? Yes. Yes, yes. So actually, not the nitric oxides, but the release, yes, so the ones that release the nitric oxide eventually.
Does phosphodiester work on anything that's a diester? Like some of the drugs that we have in here, the
Mhm.
glucocorticoids,
Mhm.
like for inhalation, and those get metabolized by phosphodiesters?
I don't think so. I think that's a totally different mechanism.
What's another drug that you use? Asthma. You said, what's another class that gets metabolized? Do you have something in mind, or were you just asking?
Oh, I was actually okay. I was leaning towards something that has to do with the vasodilation of the nitrates. Okay, so nitrates. Maybe I can show the figure of the nitrates. Okay. There is another use for phosphodiesterase, which is phosphodiesterase number 5. Okay. If we inhibit phosphodiesterase number 5, then we'll have more of this product here, and we'll have relaxation, vasodilation. Okay. Anybody knows what's sildenafil? What is sildenafil? Viagra, yeah? So Viagra is a nitrate, right? Right? Why are we not supposed to take nitrates if we take Viagra? What happens? Vasodilation, hypotension, okay? I never told you about the story of discovery of Viagra, have I? No. Okay, so Viagra actually was designed to be a nitrate. It was designed to be a drug for reducing the blood pressure by causing vasodilation, okay? And it's actually one of the side effects of the Viagra that caused, right? So when scientists discover that there is a side effect of the Viagra that causes this thing, right? They said, forget about blood pressure, right? We're gonna make billions of dollars here. And the people with blood pressure, we're not worried about them anymore, right? So that's why it's a nitrate. That's why if somebody takes Viagra, you want to make sure that they are not taking another vasodilator. Make sense? So if they're taking other classes of drugs, okay, like beta blockers or anything but not vasodilator, then that's fine. But if they take a nitrate or something that causes vasodilation and then they take Viagra, guess what? You get, double the effect of the nitrates, which means you get hypotension. You could have, what happens if you have all the blood, like accumulating in your extremities? What happens if you take the calcium channel blockers immediately? If you take calcium channel blockers without say it again. So you get orthostatic hypotension, yes. I mean, reflex tachycardia, but you also get hypotension, which you can lead to myocardial infarction, okay? You can have myocardial infarction. So that's why it's like double dose on the nitrate. That's why, the Viagra should be prevented. Okay, so I just wanted to put together how phosphodiesterase, different families can have different applications. In this case, we're talking about phosphodiesterase number 5 that causes vasodilation, and then phosphodiesterase number 4 is the one that causes anti-inflammatory. So the goal was to design selective drugs for anti-inflammatory versus, vasodilation. Kevin. So the drug would actually inhibit the phosphodiesterase, and it would lead to more of the cyclic GMP, which causes relaxation. So if you look at the nitrates, they produce the NO, which eventually increase the cyclic GMP, which causes relaxation. Cyclic GMP is metabolized by the phosphodiesterase to GMP. So if you block this pathway, you'll have more of the GMP, and then it goes that way, which causes, yes. Oh, it happens everywhere. It's just for some reason that it actually, so I mean, sildenafil itself will cause, if you take, it's dose dependent. Thank you so much. Yes. So this is a good question. It's actually dose dependent. If you give certain amount of the drug, you affect certain areas and you get the effect. If you get higher dosages, then you get relaxation over other parts. Okay. So it is dose dependent. In fact, I will tell you that, in fact, in the case of the Viagra or all these phosphodiesterase inhibitors, it's always good to start with a smaller dose, because if you give higher dose, then it might not work. So believe it or not, smaller dose might work better than higher dose. Okay. So I'll share a story with you. Okay. I knew someone who was basically trying to take 100 milligram of the Viagra, and it did not work, and they thought, I'm going to take 2 instead. I advised him to take the 25 milligram, and he was shocked that the 25 actually worked. Okay, because when you actually, there's a balance between the relaxation and contraction. I'm sure you will see that in pharmacology. Yes. Yeah. I was gonna. Anyway, so yeah, so it's actually dose dependent, these phosphodiesterase inhibitors. Okay, any questions about today's lecture? So estrifying a group, would that increase lipophilicity or decrease lipophilicity? It depends. It depends on the group, okay? It depends on the R group. So what should I do if someone misses that question? What kind of punishment should you have? Make it bonus? They should know that, right? It shouldn't be a bonus. It should be, if you don't answer this question, you fail the whole course, right? Because we stress on this so much. Any questions, guys? Well, if you have no question, I can go to my office and relax. So let's give you 3 more minutes to think of questions. If you don't, I'll leave. Kevin. Say it again. Which one is PO? Theophylline or the other? Oh, it's fine. I can't. I know it comes in. And it's available orally. The theophylline itself. Well, looks like all of them are actually orally. Tablets, liquids, tablets, liquids. Okay. Daniel? So, right. So normally you will be provided you will be provided by the structure for the drug. So you should be able to relate the structure to, yes. So, if you are given two beta blockers, then you should be able to tell which one is selective and not. If you're given two beta agonists, then you should know which one is stable metabolically or not. And you will be provided by the SAR, so you could do that. But you do not want to rely on reading these things in the exam. You should be prepared, so you should use them instead of having to study them. Yeah.
Are we going to, in the future, are we going to do more SARs and more, like, besides this class, like, organic?
Actually, I don't think so, because anytime you talk about SAR, it's medicinal chemistry. Okay. It's kind of sad, huh?
Then you have to memorize.
Yeah, I mean, yeah. Unfortunately, pharmacy school has lots of memorization. So, are you waiting? You have a class? Are you teaching a class now or something? What time? 1? Okay. Okay, so let me just see if you have any questions, any last call questions. Yes, Tarir. Yes, okay. So the question is, remember when we designed the ACE inhibitors? So the rationale was to look at the amino acids that bind to the receptor and mimic them. Well, why not using the whole amino acids by themselves? Why not using the amino acids, themselves instead of modifying them and design a drug? Bioavailability, what does that mean? Why can't we use insulin orally? It's degraded by the stomach enzymes, right? So for the same reason, if we take these 4 amino acids, then they could be degraded by the enzymes in the stomach. Sure. You have a question too? Okay, so look at the 2 structures and see what is the difference between them, and use the table to decide which one has more glucocorticoid or less glucocorticoid effect. So you're comparing the prednisone and the hydrocortisone and prednisone. I believe the prednisone or prednisolone has a double bond between 1 and 2, so it's actually more glucocorticoid. It has a more glucocorticoid, right? Yes, that's the only difference. Yeah, so the difference between hydrocortisone and prednisolone is only in the double bond at position 1 and 2, which would make the drug, based on the table, would make it more anti-inflammatory. You'll have more glucocorticoid effect. But as far as prednisone, prednisolone, hydrocortisone, and cortisone, which ones are active, which ones are prodrugs? Okay. I'm not sure what you guys said, but I'm sure you figure it out. So prednisolone is active. Prednisone is a prodrug. It has to be converted by our liver enzyme. Hydrocortisone is active. Cortisone is inactive. It's a prodrug. It needs to be converted again with the enzyme. So if you have liver problems, then you will not be able to convert the drug into the active form. So just watch for that. What's the name of the enzyme? You don't have to know that. Okay, good. You should be able to, you should be able to tell between the 2 different structures. Yes. has what? Oh no, all of them. So
Right. So
all,
what
all
if
of
they
them.
give like Metro packs with a Z pack if they have instead of-
Exactly. Yeah. It's a well. It's. I mean, it will reduce the immunity. So all these drugs it will reduce the immunity, but they are normally taken for a short amount of time, right? So guys, one of that's why cortisons are not given for a long amount of time, okay? Because they have so many side effects. They reduce your immunity. You're likely to have infection. They, can increase the sugar for people who have diabetes. That's a problem. So what about people who take these, inhalers for life, right? They take them every day for asthma and COPD. What happens? Are they taking the cortisol all the time? Well, it's locally, right? They don't get absorbed systemically. Okay. Kevin? Beta blocker. Yes. I'm sorry, beta agonist, beta 2 agonist, yes. Oh, so we have, I think, two or three examples. The Advair has what is in the Advair? Yeah. Okay. Okay, so the salmeterol, which is a long-acting beta 2 agonist, by itself, it is sold under the name Serevant. And then when it's combined with fluticasone, you have the Advair discuss. Okay. Questions?
So I heard you say earlier that you want to use the
Okay, last call for a question. Any questions? Okay, well, if you think of other questions, you can email me, okay? All right, have a good afternoon. Thank you.